Hello students and welcome. In this video we're going to go over some examples from section 6.4 on confidence intervals for the variance and standard deviation. So to answer the first two questions in the homework for section 6.4, I encourage you to read the first couple of pages. Okay, so when we read the first couple of pages, you'll find the answers to questions 1 and 2 in homework, so I'm going to go ahead and skip over those. Okay, so before we do question 3, let me go over some basic information that you need to know. So the chi-square distribution is used to construct the confidence intervals in this section. You will be asked to find critical values from the chi-square distribution in the homework. Use the chi-square distribution calculator in StatCrunch to find the critical values. Use the confidence level C expressed as a decimal and the fact that the degrees of freedom, df, is equal to n minus 1, where n is the sample size, to get the desired critical values. Okay, so you'll see some examples in the book of how they find the critical values from the chi-square distribution by using the chi-square table. Okay, so obviously we're not going to be using the table, we're going to be using the chi-square distribution calculator in StatCrunch. So with that said, let's go ahead and look at question number 3. And question 3 says, to find the critical values chi-square sub r and chi-square sub l for the given confidence level C and sample size n. Okay, so you might be asking, so what is that fancy looking X? Okay, so the fancy looking X is a Greek letter, so it's the Greek letter chi. Okay, so the way that you say this when you read it out loud is chi square. Okay, so you see an exponent of 2 means square, so chi square sub r and chi square sub l. Okay, so our given confidence level is 0.99 and our sample size is 20. So let's go ahead and head over to StatCrunch. And we're going to go to the Stat menu, Calculators, and select chi-square. Okay, so what we're going to do is we're going to take our confidence level, 0.99, okay, and we're going to select between, okay, and we're going to enter the confidence level in this box over here, so 0.99. Remember, df stands for the degrees of freedom, and it's always equal to the sample size minus 1. So in our problem, it says that our sample size is n equal to 20. So 20 minus 1, okay, so you don't need a calculator to do that. So 20 minus 1 is equal to 19. So the degrees of freedom is equal to 19, which goes in this box here. Okay, and when we click compute, the two critical values will appear in these two boxes. Okay, so it's asking for chi-square sub r. Okay, so chi-square sub r is the critical value on the right side of the curve. It's represented by the right edge of the shaded region of our graph here. So chi-square sub r, when rounded to 3 decimal places, is 38.582. Okay, and the chi-square sub l is represented by the left edge of the shaded region, which when rounded to 3 decimal places is 6.844. Okay, so question 4 is very similar, so find the critical values chi-square sub l and chi-square sub r for the given confidence level C and sample size n. Okay, so once again we look at the confidence level, which is 0.98. Okay, so remember, when using this chi-square calculator, you want to select the between option. Okay, and we're going to enter the degrees of freedom in this box here. Okay, so the sample size is 29, so that means the degrees of freedom is 29 minus 1. And so the degrees of freedom is 28. Okay, and we're going to enter the confidence level in this box here, 0.98. Okay, and if you have values from a previous calculation here, right, what you change is the value in this box, right, whatever numbers were here previously are going to be erased. Okay, so we have our degrees of freedom and our confidence level. There's a decimal, and we're going to click compute. Okay. So when you answer these questions, okay, make sure you enter the correct critical value. So it's asking for chi-squared sub L. Okay, L means left. Okay, so we're looking for a critical value on the left side, okay, which is this number here. Okay, so the critical value on the left side appears in the left box. Okay, and the critical value on the right side appears in the right box. Okay, so rounded to 3 decimal places at 13.565. So that 4 there gets rounded up to a 5, so 13.565. Okay, is the left-hand critical value. Alright, and then the other critical value is the one on the right-hand side, so we're going to round that to 3 decimal places as well, so 48.2 cent critical value. So 42.278, or 48.278, so 48.278. Alright, that's how you find critical values from the chi-square calculator in StackCrunch. So next what we're going to do is construct a confidence interval. So a few notes before we do so. Okay, so we're going to use the variance stats function in StackCrunch to construct confidence intervals for the population variance sigma squared. So remember that the symbol is sigma squared. Okay, so remember this is the Greek letter sigma. It looks like an O with a tail on it, on the top of it, so that's the Greek letter sigma. So remember that the symbol sigma squared represents the variance of a population, and then sigma without the exponent of 2, right, this is sigma, is the symbol we use to represent the standard deviation of a population. Okay, likewise, S is the symbol we use for the sample standard deviation, and then S squared is the sample variance. Okay, so you notice that the variance for either a sample or a population, right, has an exponent of 2, and then the standard deviation of a population or a sample does not have an exponent. So the variance is equal to the square of the standard deviation. Okay, so if somehow you have the standard deviation, you take the value of the standard deviation and square it on a calculator to get the variance. Okay, but if you have the variance and you want to find the standard deviation, right, the square root of the variance is equal to the standard deviation. Okay, so if you have either the standard deviation of a population or of a sample, right, you square root its value on the calculator to get the standard deviation. Okay, so let's go to look at question 5, and it says, use technology to construct the confidence intervals for the population variance and the population standard deviation. Okay, and it says, assume that the sample is taken from a normally distributed population. Okay, so you may remember in your reading at the beginning of section 6.4, okay, that it said that the data must come from a population that's normally distributed. So in order to use the method that we use to get the confidence intervals in this section, right, we have to have a population that's normally distributed. If not, then the method we use in this section cannot be used. Okay, so it says our confidence level is 0.90. Okay, S squared, okay, which is the sample variance, the variance of our sample data, is equal to 13.69. Alright, and then it says our sample size N is equal to 29. Okay, so what you have here is a summary of the data. Okay, we don't know what the actual data values are. Okay, so we have a summary of the data. So it's going to tell us what we're going to do to get our confidence interval. So let's go over to StackCrunch. Okay, go to the stat menu, and we're going to go to variance stats. Okay, because we only have one sample. Okay, we're going to select one sample. Because we have a summary of the data, we're going to select with summary. Okay, and then the very top box is asking for the sample variance. Okay, so in the problem set our sample variance is equal to 13.69. So that's the number that goes in the top box, 13.69. Our sample size n is equal to 29 that goes in the second box. Okay, and it gives you the option to do a hypothesis test or a confidence interval. So we want a confidence interval, and we're going to enter the confidence level in this box here. So we select the button for confidence interval, and our confidence level is 0.90. So we're going to enter the confidence level in this box here. And if you want to, you can create a plot of your confidence interval, but that's optional. Click compute. Okay, so on the first slide, okay, we have a confidence interval for the population variance sigma squared. Okay, so in the problem, the confidence interval for the population variance is blank and blank. So we're going to enter the lower limit in the first box and the upper limit of our confidence interval in the second box. Okay, so the lower limit, okay, we're going to round that to 2 decimal places, is 9.27. Alright, and then the upper limit of our confidence interval is 22.64. And it goes in the second box. Okay, so now we want the confidence interval for the population standard deviation. Okay, so we have our confidence interval for the population variance. Right, so how do we get the confidence interval for the population standard deviation? Okay, so this goes back to what I said earlier, right? The square root of the variance is equal to the standard deviation. Okay, so to get the confidence interval for the population standard deviation, take the square root of the limit to the confidence interval for sigma squared, the population variance. Okay, so what we want to do is square root these values, okay, rather than the our answers, okay, what we put in for our answers, okay. So because we rounded these, we don't want to square root these because it might introduce some error in our answers here, which could be incorrect, okay. So to get the confidence interval for the standard deviation of our population, okay, we're going to square root on our calculators 9.2730174, okay. So on this calculator, to square root this number, right, you enter the number first and then find the square root button. Okay, so my calculator's telling me it's about 3.119. Okay, we're going to go ahead and round that to 2 decimal places, so it's about 3.12. Here's the lower limit for the confidence interval for the standard deviation, so 3.12. Alright, and then lastly, we're going to square root the upper limit of our interval. So we're going to type in that whole number. Okay, so 22.644307. Okay, so on some calculators, you have to find the square root button first, hit it, and then enter the number, and then hit equal to. But in this calculator, we're going to enter the number first, and then take the square root. Okay, so to round it to 2 decimal places. Okay, the upper limit for the standard deviation is 4.76, so that 5 gets rounded up to a 6. Okay, so the confidence interval for the standard deviation, okay, is from 3.12 to 4.76. Okay, so tell me that at least one of these answers is incorrect, okay, which can happen. Okay, so you just have to go back and double check your work. So I noticed that it's not correct, right? It's telling me that the lower limit is this number. So it looks like I just incorrectly entered the lower limit when I took the square root of it. So let's go ahead and do that again. So 9.27, okay, 3.0174. So enter that very carefully. Take the square root. Okay, so we get 3.045. Okay, when rounded to 2 decimal places, it's about 3.05. Okay, so I believe the upper limit is correct. So we've got to change the lower limit. Okay, so 3.05. Let's check our answer. And our answer is correct. So that completes question 5. Thank you for watching.